Hello everyone and welcome to the channel. In this video, we are going to locally install this brand new model from which is Un2 Audio 7 billion Instruct model. This model is very useful for audio analysis and processing, plus you can also integrate it in your NLP pipelines. This is a new series of large audio language models, and it is capable of accepting various audio signal inputs and performing audio analysis or direct textual responses with regard to speech instructions. This model comes up with two distinct audio interaction modes. First is for voice chat. You can freely engage in a voice interaction even without inputting any text. You can stream your voice and it is going to convert it into audio. Or you could just provide it your audio and text instructions, maybe in WAV file, and it is going to do the audio analysis and it will give you the output on the basis of it. Un2 has released a base model which is Un2 Audio 7 billion and also a fine-tuned one, the Instruct model in the same, and we are going to install the Instruct one. Before I do that, let me give a huge shout out to our good friends at Mass Compute who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on good prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount on a range of GPUs. Let me take you to my terminal where I am running 1222.04 and this is my GPU card NVIDIA RTX A6000. Let me clear the screen. To keep everything separate, let me create a Conda environment and then we are activating it and stepping into it. Let's wait for it to get installed and then we are going to start installing the prerequisites. First I'm installing PyTorch and then I'm also going to install the transformers from the source because it's a very new model and it is still not available in the PyPy version. So let's wait for this PyTorch to get installed. And PyTorch is installed. And if you don't know what PyTorch is, it is a fundamental deep learning library. And then let's install transformers, which is, and I'm installing it from the GitHub, which means I'm installing it from the source. And it is a fundamental library for natural language processing tasks, mainly used for text generation and classification. So let's wait for it to get finished. It is going to take a couple of few seconds, I guess. It's not that big. Almost there. And that is done. Now let's install Hugging Face Hub and Accelerate. Hugging Face Hub is to just to access the Hugging Face, and then Accelerate to optimize the stuff. That is already done, as you can see both of them. Let's install some of the auxiliary libraries. Let me paste it all together so that we will speed it up. Now you see we are installing a lot of libraries here, um, which include Librosa, NumPy, Skippy. These are for audio signal processing, analysis, and manipulation. We also have PyDub, which is used for manipulating audio files, providing an easy to use interface for tasks like cutting, copying, and pasting audio segments. We might not use it, but it's always a good idea to install the full suite of it. Let's wait for it to finish. And that is all done. Towards the end, let's also install ffmpeg because I'm using Conda environment. So I will be just linking it to Conda by this command, Conda forge ffmpeg. And ffmpeg is quite a powerful open source multimedia framework for processing, converting, and streaming audio and video files. Let's wait for it to get installed. And let me press Y here. It is going to take a couple of minutes. And that is all done. Let me clear the screen. All the prerequisites are done. Now let me install the Jupyter notebook and launch it in the browser, and then we will download our model and then play around with it. My Jupyter notebook is launched now. Let's import the libraries and then download this into Audio 7 billion Instruct model. Let me run it. and the model has started downloading. There are 5 shards it seems. So let's see how long does it take. Model is almost downloaded and now it is loading onto our GPU. Let's wait for it to get loaded. And both the model and tokenizer are now loaded. Let's specify our audio files and process them. So if you look here, we are simply using the chat ML sort of prompt here. So this is a conversation where there is an audio file URL, and then this is the prompt which we are saying that um, this is a user, this is an assistant, and this is a again user content. Of course you can use your own um, audio files, or you could just build an application around it where you can stream the audio in a wave file, put it on your local system, load it, and then use it from there. And for loading, you can see that we are just applying the chat template here and then creating a list called as audio. From there we are just looping through it, and then using this librosa library which I explained earlier, we are simply loading it into our array, and then we are passing it to the model, to the processor, and then from there we are putting it onto our GPU. So let me run it, and that is all done. You can ignore the sampling rate argument for now. Okay, next up, let's pass this to model, the generated tokens, and then model is going to generate the output and we will decode it and then print the response. And there you go, it has responded us back into the Chinese translated output, which we also instructed in the prompt here at the top. So really good stuff. Um, and of course, you can use your own audio files if you like. Other than that, you can also do batch inference with this. You can stream your audio, but it will all depend upon your use case and you would have to alter your application. But the good thing is that the model supports all of this. Plus, you can also use any sort of speech. And the way it works is the speech is tokenized in 40 millisecond chunks, and then a model is basically predicting a token which corresponds to the next 40 millisecond of chunk, just as you would do with any text by predicting the next tokens. So it is really interesting to see that how this model is working, and it will also be interesting to see how more and more use cases comes up. For example, someone might try to synthesize audio output using this model, and because the audio encoder seems quite identical to Whisper model from OpenAI, and I think this Unto model is using Whisper Large v3, which would probably require retaining of the Whisper speech acoustic model, but I might be wrong because I don't see much architectural information on the page. But the good thing is that they have shared some of the code chunk which you can readily use in order to do the batch inferencing. So quite a good addition in terms of audio large language models, and I can see that this multimedia model could be used in various AI powered applications. Let me know what you think. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thanks for watching.